We're looking at multiplying and dividing rational functions. We're going to see how this goes. I don't have blinds on this window, so we'll see if the light becomes an issue, but we're going to go for it for right now. So multiplying and dividing rational functions. So first up, I just want to talk about rational functions to begin with. Our key words here, rational. Rational is just a fancy way of saying fraction. You might remember when we talked about number systems, a rational number is anything that can be written in form of a fraction. So 3/2, or 1/2, or 1/3, or 217/25. All of those are considered rational numbers. The function piece just implies that we have equations, aka variables. So if we take those two things together, essentially what we're looking for is we have fractions with equations as their parts. So we might see things like this. You might see something like 3x squared over x plus 2. Or you might see something more complicated, x squared plus 5x plus 6 all over x squared minus 4. That is a rational expression or function. And then we've also got 1 over x cubed. So the idea is we not only have fractions, but we have stuff on top and on bottom. So when we start doing arithmetic with these things, today our focus is on multiplying and dividing because that's the easier of the two. We start our foundation in fraction land. So we need to have in our mindset everything we know about fractions and the way they work holds the same way. So I'm going to start this lesson with us looking at some fraction pieces. So when we talk about fractions, we know that we can simplify. And when we think about simplifying, all that means is we are finding numbers that go in evenly to both the top, the numerator, and the denominator. So for example, if I gave you the fraction 6/10, I'm going to belabor the point a little bit, but that 6/10 we could think about as being 2 times 3 on top, and we could think about it as being 2 times 5 on the bottom or our denominator. Since the 2's are on both the top and the bottom, they cancel out, and you are left with just 3/5. And we have thus simplified our fraction. This core understanding will work the same for our rational expressions. In addition to simplifying, we also know that we can multiply. And hopefully you remember how we go about multiplying fractions, but if you're not quite sure or it's been a little while, I just want you to remember that when we multiply fractions, they're very convenient because when we multiply, all we have to do is go straight across. So this 3/5 times 4/11, if I multiply straight across, this just becomes 3 times 4 over 5 times 11, or is just simply 12/55. And that would be it. In addition, I also want us to remember that we can simplify as we go. So say, for example, I gave you the following. Say I gave you the same 3/5 to start with, but then I asked you to multiply by 25/12. Well, you could look at this problem and we could multiply straight across 3 times 25 and 5 times 12. But before we even get there, we could take note of the fact that this 25 is the same as 5 and 5, and this 12 is the same as 3 times 4, in which case, if I already know I have the same number on top and on bottom, I can cancel. So this 3 cancels with this 3. This 5 cancels with this 5, and what are we left with? I've got a 1 times 5 on top for my numerator, and I've got a 1 times 4 on the bottom for my denominator, or just 5/4. We can multiply our fractions. And then finally, we can simplify, we can multiply, and so that must mean we can divide. And I hope you remember how we go about dividing fractions, but in case you don't, we're right here. Let's go 3/5. We're going to keep it simple, divided by 4 over 11. And when we do this, I have a rule of thumb to help us keep track of what we need to do. And that is the following. When you divide fractions, you are going to keep, change, flip. And the idea behind it is that first fraction you keep, 3 over 5. Don't touch it, don't move it, just rewrite it. Keep the fraction. You're going to change your division into multiplication, so now we have turned into multiply. And then you are going to flip the second fraction, so that 4 over 11 is going to become 11 over 4. At this point, it's multiplication, which we saw straight up above, and all we need to do is to go straight across. So my 3 times 11 for my numerator will give me 33, and my 5 times 4 for my denominator will give me 20. So with that, we have refreshed ourselves a little bit with fractions. We know we can simplify. We can find parts that multiply together and are the same on top and bottom. We see that we can multiply. We go straight across. If we want to cancel in the process, we can. And we see that we can divide. All we have to do is keep the pattern of keep, change, flip. So what happens to go from these guys with fractions to these ugly things called rational functions or expressions? And the key is we want to take these expressions and we want to break them down like we did right here. In order to do that, we need to factor. So the deal for today is this. In this next unit, you need to have in your head that these problems are not hard, but they are tedious. Because if I give you lots of parts and you got to do a whole bunch of extra factoring, factoring in and of itself is not outright hard, but it does take some time. So with that, let's jump straight into an example. And depending on how long this takes, I'm going to do probably 3. So this first one, let's say we got right here. We got x squared plus 5x plus 6 over x plus 4. And we're going to multiply this by x squared plus 2x minus 8 all over x squared plus 6x plus 9. Here's the deal for this lesson. I'm going to take 2 or 3 spots to kind of remind us about the factoring process, but ultimately I'm going to kind of shortcut a little bit. And part of this is because some of these are quick enough that you hopefully can already understand what they're going to factor into. By all means, you have full strategies available to you, so do not hesitate to draw out the area model or show all necessary steps. The first thing I'm always going to do is I want to just get all my parts factored every single time. So I want to turn each one of these guys into its factored form. So this x squared plus 5x plus 6, I want to turn into the 2 sets of parentheses that are going to multiply together to make that. Now, to give myself a little bit of room over here, I'm going to take that x squared plus 5x plus 6. I'm going to belabor the point just to kind of showcase this a little bit, and then we'll cut to the chase. So when we did the area model problems, we kind of went through a process where we took the first term x squared and the last term 6 and we stuck them on one diagonal. We then found their product, in which case it was 6x squared, and we told ourselves that we needed to multiply to get to 6x squared, and we needed to add to get to this middle term, which is a 5x. So now we're asking ourselves for 2 numbers that multiply to 6 and add to 5, and in this case those numbers would be a 2x and a 3x. So we can add the 2x and the 3x to the other diagonal in our box, at which point we are now looking to pull out GCFs in every row and column. GCF standing for greatest common factor. What's in common between an x squared and a 3x? They have an x in common. What's in common between a 2x and a 6? They both have a 2. X squared and a 2x have an x, 3x and 6 have a 3, and so this top problem up here factors into x plus 2, x plus 3. Obviously, from the get-go, you could look at this problem and say, hey, two numbers that multiply to 6 add to 5. 2 and 3. Done. Awesome. I hope you're doing that. But realize you always have full permission to write out your work, show your steps. Factoring shouldn't be a struggle at this point. I'm going to cut to the chase. I'm going to do the other ones. This one right here is going to become x plus 4 and x minus 2. Notice that there's one positive and one negative because they multiply to a negative number. Down here I need two numbers that multiply to 9, add to 6. Those are going to be x plus 3 and x plus 3. Now, from a multiplying standpoint, I get to take everything across the top, which would be all 4 of these parentheses. I get to take everything across the bottom, which would be all 3 of these parentheses. But why not take advantage of the fact that I can simplify first? So I see that this x plus 3 right here can cancel with an x plus 3 down here. I see that this x plus 4 on top can cancel with this x plus 4 on the bottom. At this point, there's nothing else that I can cancel out. So my answer is going to be the parts that are left. I need an x plus 2. I need an x minus 2. And finally, I need an x plus 3. Boom. And we're done. Now here's the deal. On some multiple choice tests, especially in the SAT, you will see this work multiplied out. So they won't leave their answer with parentheses. However, for our purposes, this will work. You're going to see a little later on in a future lesson, I actually like when this is broken up. And part of that's because anytime we're trying to find interesting points, we're just going to have to factor the parts apart anyways, so why not just leave it like this? I don't care that there's some extra parentheses in there. It helps us find the interesting points easier. So yeah, that's our first one right there. I'm going to jump on to a second one. So example 2. Gives me a second to just write it down. I'm going to go right here. I've got x squared minus 9 over x squared, I'm going to kind of repeat myself a little bit, 6x plus 9 times x squared plus 1 over x squared plus 2x minus 15. So same as before, step 1, we can't see that. Same as before, step 1 is going to be to factor everything. I specifically chose these for a couple of reasons. Some because I'm lazy, others because I want to showcase something. First one I want to showcase, this first one right here, x squared minus 9. X squared minus 9 is a special factoring problem that you might be aware of. I'm going to go over it to belabor the point, but right here I start the same as I did before. I've got my first, I've got my last, they multiply to a negative 9x squared. Now the question becomes, what do they add to? Because there's nothing in the middle right there. Well, if there's nothing in the middle, then sure enough, I have 0x. So I need to multiply to a negative 9, and I need to add to 0. Well, if I multiply to a negative number, that means a negative and a positive. If I add to 0, well then they must be the same number, and sure enough, negative 3 and positive 3. I get at this because when I take that negative 3 and positive 3 and I add them to my box and I pull out my GCFs. So here's an x, here's a 3, here's an x, here's a minus 3, because minus 3 goes into negative 3 and negative 9. Look at your factors. X plus 3, x minus 3. That's not a mistake. And so anytime you see this difference of squares, x squared minus 9, remember that it's the same number, just opposite signs, and then that's how you get the 0 for that middle term. Going down the list right here, x squared plus 6x plus 3, we already did that up above, so I'm going to write x plus 3 twice. X squared plus 1 is kind of interesting. Let's suppose for a second that we came over here, not sure what to do, so we're trying to spread it out. So we did x squared, we did a 1, so we get a 1x squared, and then we get 0x because there's no middle term, and it's positive, which means they're either both positive, but I can't take two positives and make them add to 0, or they're both negative and same thing, and I can't take two negatives and make them add to 0. So it turns out that that's not factorable. So do be prepared that you might occasionally see problems where one of the parts isn't factorable. It's not a guarantee that you're always going to be able to break it up into smaller pieces. And then finally, this one down here, I want you to just mentally think for a second. You need two numbers that multiply to a negative 15. What does that mean about your signs? And they have to add to a 2. And so see if you can think about what those two numbers are. Multiply to a negative 15, add to a 2. And it turns out those numbers will be x plus 5 and x minus 3. So now we're in the same spot as we are before, where we've factored everything, in which case I want to cancel as much as I can. So I see an x plus 3 on top, which will cancel with an x plus 3 on the bottom. I see an x minus 3 on top, which will cancel with an x minus 3 on the bottom. And nothing else will go anywhere. So when we go to write our answer, what we have left is the x squared plus 1 on top. And on bottom, I've got an x plus 3 and an x plus 5. Again, I'm totally okay with you just leaving the parentheses. The only thing I'll mention is if you do leave the parentheses when you go on MyOpenMath to submit your answer, please, please, please click the preview button, okay? Because that preview button will show what you type and make it look mathy. And the point there is it's going to highlight, you might type this in, and depending on how you type it in, if you don't have your parentheses in the right spot, you might need extra. It wouldn't be unreasonable for your answer to end up looking something like this, and then it ends up putting the x plus 5 on top. If you don't have enough parentheses. So just please click that preview button. When in doubt, put an extra set of parentheses around a denominator or around a numerator, just to make sure you're entering what you think you're entering, because I think that's where there might be a little hiccup. So personally for me, I'm always going to put an extra set of parentheses for the denominator and an extra set of parentheses for the numerator, and I know I'm good. It takes a little bit extra type in, but you've got everything covered. Okay? So, with that, let's do one more. Last one. Example 3. So, example 3 right here, we got x squared minus 4 all over x squared plus 5x minus 6. That's not a minus 6, that's a plus 6. And we'll multiply that. Oh, I don't want to multiply. I can't even prepare my own notes properly. We want to divide. And if I divide, making sure this still works, yes. I've got x squared plus 4x plus 4 all over x plus 3. Cool beans. So we're looking right here. We got x squared minus 4 all over x squared plus 5x plus 6 divided by x squared plus 4x plus 4 all over x plus 3. Step 1 has not changed. I want to factor all the things. I'm going to use our shortcuts from up above. I've got a difference of squares right here. I've got a perfect square. I've got a perfect square. 2 times 2 is 4. They're being subtracted. So I can turn that into x plus 2 and x minus 2. X squared plus 5x plus 6, that's not too challenging. Two numbers that multiply to 6, add to 5, will be 2 and 3. And then I come over here, x squared plus 4x plus 4. Two numbers multiply to 4, add to 4. Well, there's not much choice there. And sure enough, that is x plus 2 and x plus 2. And then we've got our x plus 3. However, you gotta be careful because we got division this time. So if we follow our blueprint from before, our blueprint says that we need to keep, change, flip. So here's the deal. I keep that first fraction. So that first fraction will be x plus 2 x minus 2. I'm going to move up just a little bit. Nope. X plus 2, x minus 2. My denominator stays the same, x plus 2 and x plus 3. I need to change. That division is going to become multiplication, and my second fraction will flip. So now the x plus 3 is on top, and the x plus 2 is on the bottom. And now I can treat it like a normal multiplication problem. So my x plus 3 term right here will cancel top and bottom. I've got an x plus 2, which will cancel top and bottom. And at this point, there is nothing left to cancel. So when I multiply straight across, I've got an x minus 2 on top. I've got an x plus 2, and there's 2 of them. So if you wanted to, you could group that denominator together, and you could write it as x minus 2 and x plus 2 squared. That would be okay. Just to hint at typing it out as well, if you multiplied that out, you could also have x squared plus 4x plus 4. All of those are equivalent answers. Regardless of what you're typing in, my encouragement stays the same. When you type this in on MyOpenMath, please, please, please put an extra set of parentheses around your numerator and around your denominator, because that should help with formatting issues. And either way, make sure you hit that preview button, because it'll give you some insight in terms of what the computer is seeing. The program is set up where it would take any version of these. It evaluates your function to see if it's equivalent, so it doesn't have to look a specific way. I did that on purpose. So hopefully that brings some clarity for this first topic. Please message me. If you get to a question that doesn't make sense or the answer's not working properly, you can email that question directly to me when you ask for help. That way I can see your work, I can see the problem, and I'm coding these questions, so I'm not saying I'm perfect, and there probably are some glitches. So if you find something that is behaving weird, let me know, because that means I need to fix something. So I hope you're doing well. I hope you're having some fun with your more flexible schedule. Let's get to it. Let's do some math. Let's learn some things. Let's bring something new to the table. So with that, I will talk to you soon.